Hi. So yeah, today most of this focus is going to be around the things that we've learned at SkyKick about how to automate SaaS applications. To kind of give you a little bit of background on who we are, our only mission is really to help people be successful in the cloud. And we have backup and migration and other management products that we've built. And our journey has really been from our first partner to now over 20,000 partners. And how do we grow at a rate in which they can grow with us, and that we've kept our focus on our core technologies, that partner experience, and again, automation. How do we enable people to go faster? How do we reduce the time it takes for partners to onboard people to the cloud? There's really four themes that we're going to kind of hear through this. It's about incremental improvement. How do we build on top of it? Iterations. Repeatable designs, taking things that work and just continuously reusing those capabilities. Innovation, like I think people from some of the other sessions have talked about this too, is you have to be willing to think outside the box and come up with new ideas. And then focus on what you're good at. So don't reinvent tools and solutions out there. Try to leverage what's out there. And so to kind of set this up, I think we're going to start with some good examples of onboarding people and automations. I'm sure everybody has heard about Slack. They had a session earlier. It's one of the fastest growing SaaS applications, and for a reason. Their onboarding experience is very, very easy. By the time I finish this slide, you could have set up your own Slack environment probably. There's just the setup from the email and the domain to inviting a couple people, and then you're in it, you're using it. And that's a great story for people, and it makes it very fast for adoption. The other advantage there is there's tons of opportunity. They have lots of applications you can integrate, and that creates an ecosystem for people to kind of to build on and support and use and really embed, and keeps them a very sticky engagement with that customer. Again, very simple, very easy. But then there's more complex ones. So Office 365, this is an area where our company has focused a lot of our energy. Setting up one or two people in that is very simple. You can see there's just a real simple little screen. You put in their name, email address, a few permissions, and it's done. But if you scale that to hundreds of people or thousands of people, suddenly it becomes really complex. And it's important to make sure that the simple things are simple, but the complex things have to be possible. And so Microsoft has done a great job. They've created PowerShell. PowerShell is this easy way to automate some of this setup. But even this, it's not complicated, but it's not actually setting up a user correctly. There's a ton of missing information around there around permissions, licensing. And so when you start to do that at scale, now you're talking about importing CSV files, automating it. Now you're starting to code, and you're pushing a lot of effort down to people. And then, of course, it's Microsoft, so they evolve. So, this PowerShell was valid at one point, but now there's, more powerful AAD mechanisms for Azure Active Directory. And so it becomes more and more complex over time. And so what we don't want to forget, though, is that there's still opportunity to make this simple. Like, don't look past just the fact that it is possible to make it happen, but how do you continue to make it simpler? And so that's really what we focused on, was how do we take those opportunities and maximize it for our partners to make it simpler for them to onboard and use cloud services. Something like PowerShell is like an easy example of this. That's the single complex aspect that can easily be automated, wrapped with a front end, and made easier for people to consume. But what are the things beyond that? Like, what are the non-obvious engineering problems and solutions that need to be solved that make it easier for your customers, your partners, to adopt your technologies? And so for some of that, you have to look past like the basic definition of this. For instance, here's the Wikipedia definition for hyperscale. It's really focused on the ability of an architecture to scale appropriately as a system expands. So that makes sense. It's something that every engineer, every developer thinks about. How do I build my systems to scale out? That's a well-known issue. The other question is then, how do you go past that? And this is really where SkyKick has tried to accelerate this. And so I'm going to borrow a slide because my daughter was sick while I was making this. We were watching Toy Story. But you really want to take it to infinity and beyond. Identify your customers' doubts, identify their customer issues that they have, and try to reassure them with those things. Look at what are the analog and the manual aspects of that onboarding, and try to figure out a way to make that simpler and reduce the complexity for them. And so we're going to talk about a couple examples of how we've done that. So if you're doing an email migration, for instance, one of the important things is you have to have a domain name somehow to be able to route that email. This is how DNS propagation and lookups work. It's really complex. It adds a lot of doubt. There's a lot of uncertainty, like, has this change been effect? It could take technically 24 to 48 hours to propagate this change throughout the internet. And so that creates a lot of concern, a lot of worry. And so one of the first things that we did was try to figure out, well, how do we reduce that? And how do we take that complexity and actually turn it into like a benefit for us and add reassurance to our partners? So we just took literally a very, very simple workflow and automated it in the cloud. Send an email, see if it actually gets there. If it gets there, well, now you know that DNS propagation works. You take that manual step of an engineer, a sales op, a DevOps person from trying to go and investigate this. You take away the concern from the customer's aspect of having to go figure out, is my email actually working correctly? And so taking these little simple automations that you can then power and run by the cloud, obviously, in parallel, in mass, is just a first step towards doing that. And you want to stack on these little automations. One of the things that I've always said is you want to find the things that really annoy your team. I can tell you back in the day, 5 years ago, we had people literally sending emails trying to see if email was working correctly. It's kind of silly to have to do that. We have partners. We have the cloud. We basically have this infinite resource of compute, and let's partner with them. Let's find all of the things that have always kind of bugged us, annoyed us, and use those to kind of drive this automation. One of the things that I can say is, for most SaaS applications too, like that very, very first step is a human step. If you think of Slack, you have to go to this page, you have to sign up, you have to go to Office 365, you have to purchase something. So how do we actually start to look at that sign up, order placement, the very first steps, and try to even figure out how do we automate those things? So again, one of the things I mentioned before is we want to look at using existing tools. So Microsoft has APIM, their API management tools. It has a bunch of built-in capabilities around publishing, managing, securing. This was something that we could look at as a way to kind of automate away that first manual step. How do we take people from going to a keyboard and manually placing an order to having systems that are in the back end automatically connecting to us, placing those orders, and eliminate that human error step? If you think of something, going from 10 orders to 100 to 1,000, if you have people doing it, it's going to be error prone. It's just the nature of it. So if you can move it into a system where it's automated, it's obviously going to scale much better. And so this is an example of this is our actual graph of the way that we tested and adopted one of our partners to scale up. And so, we started at a very low rate. We tested it. We had a certain fixed amount of orders that could get placed every hour. And we tested and we found all of the inefficiencies in our systems. There's a lot of kind of ripple things that you don't think about. If a person places 10 orders at once, you may have a lot of triggers that are firing off simultaneously. So you kind of want to test and ramp that up. And once you get to a level of comfort, then you ratchet it up and you say, okay, let's open up that gate, have a little bit more flood come in, and understand what we need to do to our system. And we do that iteratively over multiple steps, and that allows us to basically 4 or 5x, 10x the way that our customers adopt our platform without having to worry about how's the back end going to handle that kind of system change. All right, so how do you break that actually down though and make it effective? I guess that's the next point of this. So the way that I always kind of think of this is it's a full life cycle. DevOps is a term that is obviously well used in our community. There's a lot of sessions around DevOps today. I'm certainly not going to give it as a good example and a good definition of it as they are, but I can break it down into really 3 things that was critical for us to be successful. And it's really around build your product, test it, monitor it, and iterate again. And so these 3 areas are really what we focused on as tightly and as closely as we possibly could. So the first step is your product. You have to go build something that has value that people are going to go consume and use. So I'm using our APIs as an example. The APIs are a nice one too because it's a very, very clean surface area for testing and for monitoring. It's got known signatures, known inputs, known outputs, very, very testable. And so once we had that, while we were building it, we started to build in automation testing. So this is an example of one of our actual reports that gets sent out, and then we track historical. And this shows all of our automation testing, and it's showing our daily build tests again. So this isn't like planned integration testing or planned release testing. This is just happening every day, every night. Now our systems are actually more complex. They have continuous integration, so we build on every check-in. And so we're always having this kind of evaluation of our systems capabilities. But importantly, we want to track what's that percentage. Is it generally working? And you can see the spots in yellow there are probably major refactors to our system, something that we changed in the background. We had some breakage, which is normal, but we actually were able to detect it and fix it before we actually have releases. And that's really the key piece, is you want to have that automation even internally. So our partners, our customers never see this, but internally we're running this automation to make sure our platform's stable. Okay, so now that you have some testing going on in your production, or excuse me, in your development environment, now you need to move to your production environment. And so one of the things that we did is we used Datadog, for instance. I'm not necessarily selling Datadog or advocating for it, but there's select tools out there that you want to try to leverage. The things that we really wanted is we wanted to have good integrations to the rest of our platforms, things like Slack, our email system, Office 365. We want to be able to customize it. And then another important trend out here is AI and machine learning. And so this has built-in trend analysis, anomaly detection, all of the things that we don't have to go spend our time trying to figure out and understand, but we can just leverage out of the box, basically. So in this example, there's a couple things I want to point out. One, we run long-term tracking of performance. Our warnings are there to alert us of potential problems, not just when we know there's a problem, but is there a potential problem? And then it gives us really good indicator as to what it is. So there's specific information. You can also see that there's like a Slack channel listed in there. Again, that integration into our systems, where we work, how we live every day. So we don't get distracted with an email and have to change. Slack's running on one of our monitors, and our engineers get alerted whenever there's an issue. They can then monitor it, trend on it, and then decide if they have to escalate it. We also have integration with things like PagerDuty and stuff like that. So as they escalate higher, we get notified when necessary. Another aspect of this is what happens once you've gotten your basic warnings in there? How do you actually start to solve it? Again, you can think of it as, I have a highly trained team of engineers who know what every message means and what every log file and analysis says. That really doesn't scale again either. You want to think past that. So in this example, it's a little tough to read probably on these slides, but you can see there's actually specific steps. What does the new engineer, the new guy on our team, need to do to go kind of solve this? And how do they go through this process and work on it? And so this block of message can be sent, again, through PagerDuty, through IM, through Slack. And so now they're able to go fix this without having to go coordinate more people and talk. We're pushing down that knowledge and spending the time to automate that as quickly as possible. Let's see. The next thing is, okay, now scale it up. So start to build dashboards and build real true measuring and analytics on how is your overall system performing. And so you can see this is an example of one of our dashboards. It talks about all the different regions in Azure where we're running our workloads. And there's a couple of interesting things that I want to kind of point out. So one, we've designed our systems to be as idle as possible and then to automatically scale when necessary. So our tools are smart enough to know that we're going to get these weird, spiky little situations happening because nobody's doing anything. And then somebody comes in and places a large order. Let's say there's 1,000 seats that we need to move to the cloud. Well, now suddenly we're behind because they just placed that order. So we're going to notice that spike that comes up. But then we're also going to go deploy resources on it automatically and then take that spike back down. And so using a tool that's smart and intelligent will also learn that that's a normal usage pattern for us and then not artificially flag those kind of errors. It's really helpful because what we can do is not just hard code thresholds. I think it was one of the speakers this morning that said, you went from a rules-based set to machine learning-based set. So we're no longer saying if it goes above 100, everybody freak out. It automatically can figure out if it's been over 100 for too long of a period of time, then it'll start to warn us. And the other thing that's important to notice, there's blank spots. The blank spots are the cost savings. If you're not running resources and you're not paying for them, that's perfect. When you need them, you want to spin them up and actually deploy these things. Let's see. The last one here is kind of talking about the timing. So if you're running a live SaaS application, you certainly want to know about problems before your partners do or before your customers do. And so in this example, we're tracking this down to like a 5-minute window. If our applications aren't being responsive, or if one of our services, one of our microservices, I think this one might be ingestion, how do we receive data and how fast can we process it? If we notice that there's an issue with that, we want to find out as quickly as possible, because the chances are the faster we find out, the quicker our response will be to be able to rectify it. We might be deploying more services. We might realize that Microsoft rolled out some sort of patch and now we have to go adjust for it. And so we can either throttle down or throttle up appropriately. Ideally, these systems are, again, automated, but we do want to try to put as much official automation around it as possible. So a couple things. So I want to kind of recap and come back to a few specific things. So one, again, the incremental approach to this. I came from a traditional software background. We built software for 911 agencies. So we literally build software for months and months and months, and then you go to them and you deploy it once. You have one window to take down 911 agencies. We're in the cloud, we can do continuous deployments, we can update as often as we want. If you design them correctly, which again is an evolutionary thing, you can even get to the point where you have rolling upgrades. People don't notice there's any downtime, and you continue to embrace like the microservices approach. Then you're only limiting yourself down to certain key pieces of this anyways, and so it's not the full monolithic platform that has to come down. And really take one step at a time. I know one of my favorite examples was when I started, my boss, the CTO, said, "So glad you're here. Every Saturday I get up in the morning and I go check all of our systems and make sure that they're still working." And I was like, "Oh, I'm excited to do that for you." But I wasn't, but I was a good employee, so I did it. But as soon as we hired the next guy, I was like, "So I have a great project for you. I want you to go build me a dashboard that shows all of our services and says whether they're up or running or not." So he goes and he does that. It looks great. I was like, "Perfect. So now all of these that we know about, I want you to put a button that says fix it." And he was like, "Oh, okay. So now I know how to go fix it. I reboot the service or change some flag in the database." We test that out for a couple weeks and it works. I'm like, "Great. Can you write some JavaScript that clicks that button automatically for me so that I don't have to go look at it?" And it literally was that kind of automation that we've done over maybe a 6-week or an 8-week period that allowed us to test it, verify it, and eventually replace it. And so now I can say, thankfully, it's been like 4 years and I've never logged onto that dashboard. Repeatable design. How do you keep using the technologies that you've built? One of the things that we did from the very beginning was this idea of a generic, we call it a CTP, like a generic way to process automation on the web, and host it in Azure and to scale it up automatically. We're able to build a team very, very quickly and have them add a lot of capabilities by just reusing that same technology. Innovation. I showed you the Datadog. One of our engineers came to us and said, "Hey, we have a bunch of Power BI reports and other things that we go and check manually. I'd love to just put some automation around this." I'm like, "Go do it." And so he went and evaluated tools. There wasn't a committee. He went and did it in an afternoon, put it on a couple agents, and we tested it and found out it was valuable. And so that was an ideal way to just kind of go fast without having to really think about it. And then lastly, like I said, leverage these tools. Don't reinvent things. Stay to your core business model, and then it makes it easier for you to adopt technology. And so that, although I feel like it was a speed run for 30 minutes, is the end of the presentation. Is there any questions? Yes. Slack goes down, yeah. Well, so 2 things. So one, when a major technology goes down like that, like everybody actually starts talking to each other in person. So it's interesting, and we do hear about it. We also have a wall of monitors where we can monitor these things. So in our, we have an open office space, and we have a DevOps area. And on the DevOps area is an entire wall of monitors, and they cover all of our various applications. So that's where we would notice it. But it also, again, is multi-integration. So it sends it to Slack. It'll send us an email. We use PagerDuty, so it'll text you. If you didn't answer that within 20 minutes, then it calls the next guy. So it is very, very automated across multiple things. Any other questions? If not, thank you.